Welcome to College Algebra. This is our first section, section 1.5, quadratic equations. First of all of these sheets that I fill out in these lectures, they are available to you within Blackboard. Just look under Files. You can download these and print them out yourselves just to follow along. The first three sections we cover in this class, all of those sections from Chapter 1, they are review. Now, when I say review, I do not mean that I expect that you remember all of this perfectly. If I expected that, then I wouldn't be covering the material. You should be looking at this and saying, oh yeah, I remember doing that. I remember doing this. I remember doing this as we go along. Okay, so first off, some definitions. A quadratic equation is an equation that can be written in the form ax squared plus bx plus c is equal to 0. That a cannot equal 0, okay? This square term has to be there in order to be a quadratic. We can't have an exponent larger than 2 either, okay? We're going to have several methods for solving these things. The first thing we need is called the zero product principle. It's something you probably know, but you may never have thought of in exactly this way. Now, what this principle says is that if a times b is equal to 0, then either a equals 0 or b equals 0. In other words, if you multiply two numbers and you get to 0, then the only way that can happen is if at least one of the two things you're multiplying is 0. There's no other way to get 0 as the answer to a multiplication problem. Okay, so what do? We need to solve these equations by factoring, okay? When we're talking about factoring, that means we're going to rewrite things as a multiplication. Okay, that's what factoring means. Right here, we have what I consider overall a subtraction and addition problem. Now, what I mean by that is if you can imagine plugging in a number for x and then following the order of operations to get the calculations down, the very last thing you would do, the very last calculations you would make are the additions and subtractions. And what we want is for the very last operation we do as a multiplication. Okay, so when you're going to solve by factoring, you have to have a 0. If this is not a 0, we can't apply the zero product principle, and so we don't have anything that works, okay? Now, we want to factor this. There's no number in front of our x squared, and these are perfect squares, but if I take the square root of x squared, that's x. Take the square root of 36, it's 6. If I multiply those together and then double it, I get 12x, which is not negative 13x. So this is not a perfect square trinomial. That means I'm going to need two numbers that multiply to a 36 and that add to a negative 13. And the numbers that will work are negative 4 and negative 9. They multiply to a positive 36. If you're multiplying to a positive number, you're either going to have two positives or two negatives. And we want to add to a negative number. And so since these have to have the same sign in order to multiply to a positive, we make sure that they are both negative to work here. So this factors as x minus 4 times x minus 9 is equal to 0. Now since now we have two things multiplied together. If I were to plug in a number for x, I would do these subtractions, and then I would take those answers and multiply them. So the very last thing I would do is a multiplication, so this thing is factored. Now what we do is we take each factor and set it equal to 0. So we do x minus 4 equals 0, x minus 9 equals 0. Now I'll solve each of these, move the 4 over, move the 9 over, and you get x equals 4 and x equals 9. Now generally speaking, whatever the largest exponent is on your polynomial, this section specifically, we're dealing with what we call second degree polynomials, where our largest exponent is a 2. Whatever your largest exponent is, that's how many answers you should expect. And that's going to become important as we go along in the course. So I have a 2, I expect 2 answers. It is possible that you get the same answer twice. but usually we're going to get 2 answers. And when you have more than one answer, you really should write it as a set, which means it goes inside braces and you list every possible answer. It does not matter what order you put these numbers in, but since so many of our things do matter, I just generally put them in order so I don't have to try to keep things straight. Okay, so let's work 9x squared plus 9x plus 2 is equal to 0. I have the 0 I need, which is good. Now I need to factor this. I look for a least common denominator, something I can factor out of all of them, not a least common denominator, a greatest common factor. Sorry, I misspoke. Look for a GCF that can factor out of this, and there's nothing, okay? I have a perfect square here, but not here, so it's not a perfect square trinomial. I'm going to factor this kind of problem when I have a number in front of my x squared and it's not a perfect square trinomial. I'm going to use the factoring by grouping method on this. If you are good at what I call guess and check, where you just try some binomials and multiply them back together and see if they work, if you're good at that, by all means keep doing it. For me and for a lot of people, that takes up a lot more paper and a lot more time. So what I'm going to do is I'm going to multiply these two things together. 9 times 2 is 18. So I'm looking for two numbers that multiply to 18, and I want them to add to a 9. And the numbers that work would be 3 and 6. They multiply to a positive 18, they add to a positive 9. Now we don't get to just rewrite this one like we did up here. We are going to replace this 9x squared plus, it really doesn't matter which of these you put first, plus 3x plus 6x plus 2 is equal to 0. All I've done is I've taken this 9x and split it up like this. If you consider combining like terms, you can see that you get right back here. So I haven't fundamentally changed the problem. What I have done though is this combination of numbers is the only combination that will make factoring by grouping work. So now I can group these two, and then I can group these two. Remember, when you're going to factor by grouping, you really want a plus sign in the middle, or you have to be prepared to factor out a negative number just to make things work. I usually try to get a positive number there. From these two, I can factor out a 3x, and that will leave 3x plus 1. From the second two, I can factor out a 2, which is 3x plus 1. Equals 0. Now these two should be the same. We write that down once. Technically what we're doing is we're factoring out that binomial. And then we have 3x plus 2 left, which is 0. Now we have this thing factored, so we set each part equal to 0. 3x plus 1 equals 0. 3x plus 2 equals 0. And we solve these. Here I'm going to subtract 1. Here I'm going to subtract 2. So I got 3x equals negative 1. Divide both sides by 3, x equals negative 1/3. Subtract 2, 3x equals negative 2. Divide by 3, x equals negative 2/3. So our two solutions are negative 2/3 and negative 1/3. Okay. Now here, I have 5x squared minus 20x is equal to 0. I have the 0 I need, which is good. I do have a GCF here. I can factor out a 5 and an x. And that will leave x minus 4. That still equals 0. Now this is factored. You set 5x equal to 0. You set x minus 4 equal to 0. Divide both sides by 5, we get x equals 0. Add 4 to both sides, and we get x equals 4. So our two solutions are 0 and 4. Okay, don't panic with a 0. Zeros are perfectly good answers. I see this a whole lot. Students find that they get 0 and they're convinced that they are absolutely wrong and it's impossible, and they put giant X's through it and scratch everything out. Zeros are good answers. If you think about plugging in a 0 here, you can see that it works out. Okay?